Okay, today we're going to look at how to solve systems of equations in two variables where some of the equations are nonlinear. And so that just means that the powers of the variables is greater than 1. So like in this first example, it says solve the system x squared plus y squared equals 25 and x minus y equals 1. And so as a step 0 in this process, I recommend trying to visualize what the solution set is going to look like geometrically. So this first equation is a circle, which I've plotted. It's a circle of radius 5, centered at 0, 0. And the second equation is a line of slope 1 that's going to pass through the y-intercept of negative 1. So I'm expecting two solutions here. So I'm just, see here, you would expect two solutions in the generic case anyways. And now we need to figure out how to find those two solutions. So what I'm going to do is in step 1, I'm going to solve for y. So you take x minus y equals 1. If you add y over and subtract 1 over, you get y equals x minus 1. And now you're going to plug that into the other equation, which is x squared plus y squared equals 25. So I get x squared plus y squared, which is x minus 1 squared, equals 25. And now I'm going to FOIL the x minus 1. So I'll get x squared plus x squared minus 2x plus 1 equals 25. And so this is a quadratic equation. So I'm going to move everything over to one side and write it like a quadratic equation. So this is going to be 2x squared minus 2x minus 24 equals 0. And so now I'll factor out a 2. So I can now get x squared minus x minus 12 equals 0. And now I can try to factor the x squared minus x minus 12. So I'm thinking of things that multiply to give me 12, 3 and 4, 2 and 6. I think 3 and 4 works if I take x minus 4 and x plus 3, that will work. So I get 2 times x minus 4 times x plus 3 equals 0. So either x equals 4 or x equals negative 3. Those are my two options for x. Okay, which kind of matches with this picture over here. This would be like the negative 3, and that'd be the x equals positive 4 there. And so now what I need to do is plug those into the original equation. So plug x equals 4 and x equals negative 3 into x minus y equals 1. Or you could write that as y equals x minus 1, right? Okay, so if x equals 4, I get y is equal to 4 minus 1, which would be 3. So that tells me that 4 comma 3 is a solution. And if x equals negative 3, then I get y is negative 3 minus 1, which is negative 4. So then negative 3, negative 4 is also a solution. So my solution set is going to be 2 points, 4 comma 3, and negative 3, negative 4. Okay, so now I know exactly the coordinates of these 2 points. I have, this would be the negative 3, negative 4 point, and this would be the 4 comma 3 point. Okay, now in this next example, we have, we have x squared plus y squared equals 16. So that would be, that'd be a circle of radius 4. So that's my blue equation is a circle of radius 4. My red equation is, this is x equals y squared minus 4, right? So then if x is negative 4, y is 0. That's this point right here. Yeah. So I'm pretty sure that I'm expecting 3 solutions. Okay, so to start, let's solve for x. In the top equation. So y squared minus x equals 4. So that means that x, if I add x to both sides, I get y squared equals x plus 4. So x equals y squared minus 4. Okay, so I've solved for x. Now I'm going to plug that into the other equation. So plug x equals y squared minus 4 into the circle equation, which is x squared plus y squared equals 16. And so that will give me y squared minus 4 squared plus y squared equals 16. And now I need to kind of FOIL that out and simplify. So this is y to the 4th minus 8y squared plus 16 plus y squared equals 16. And so now when I subtract 16 from both sides, I end up getting y to the 4th minus 7y equals 0. And so what do I get? I either get y squared, so sorry, 7 minus 7y squared. So this is either y squared equals 0 or y squared minus 7 equals 0. And so I think either y equals 0 or y equals plus or minus the square root of 7. Those are my three possible y values. And now I need to plug those into the x equals y squared minus 4 equation to get the solution. So step 3 will be plug y equals 0, y equals the square root of 7, or y equals negative square root of 7 into y squared minus x equals 4 to solve for x. So when y equals 0, I get 0 squared minus x equals 4, so x equals negative 4. So that tells me that negative 4, 0 is one of my solutions. In fact, it's that one right there. If y equals the square root of 7, then I'm getting square root of 7 squared minus x equals 4. So that's 7 minus x equals 4. So that's x equals 3. So 3 square root of 7 is a point there, and I guess that would be this one. And if I plug in negative square root of 7, then I'm going to get the same thing. So negative square root of 7 squared minus x equals 4. So that's 7 minus x equals 4. So x equals 3. 3 negative root 7. Okay, so then my solution set is those 3 points. The solution set is, let's see, negative 4, 0, 3 negative square root of 7, and 3 square root of 7. Okay. Now we have another system of equations. This one is the intersection of an ellipse, which is the 2x squared plus 3y squared equals 21, and a hyperbola, which is the 3x squared minus 4y squared equals 23. So let me say that this right here is kind of a squash circle. Looks something like, looks something like this. That's the 2x squared plus 3y squared equals 21. Notice that it looks a lot like x squared plus y squared equals 21, but you have these coefficients there, so that's like a squash circle or an ellipse. So this is an ellipse. And the other one is a hyperbola. And that is 3x squared minus 4y squared equals 23. So all I'm going to say is that looks something like that. And so our guess here would be that we'd get 4 solutions. Okay. So that's this guy. Okay, so the blue equation I'll call A, the red equation I'll call B. And so we can start by eliminating y squared. So I'm going to eliminate y squared by taking 4a plus 3b. So let's see here, that would be 8x squared plus 12y squared equals 84. And 3b would be 9x squared minus 12y squared equals 3 times 23 would be 69. Okay, and I'm adding those. So I should get 17x squared equals, let's see, 70 plus 83 would be 153, I think. Yeah. Okay, so then divide both sides by 17. I'll get x squared equals 153 over 17, which is 9. So x equals plus or minus 3. Okay. Now we take x equals plus or minus 3 and we plug that into the other equation. So step 2 is plug x equals plus or minus 3 into, let's see, the 2x squared plus 3y squared equals 21. So when x equals 3, I get 2 times 3 squared plus 3 times y squared equals 21. So then that's 2 times 9 is 18. 18 plus 3y squared equals 21. So then that says 3y squared is equal to 3. So y squared equals 1, or y equals plus or minus 1. And now when I plug in x equals negative 3, I get pretty much the same thing, because it's 2 times negative 3 squared plus 3y squared equals 21, which again is going to give us 18 plus 3y squared equals 21, so 3y squared is equal to 3, and y squared is equal to 1, so y equals plus or minus 1. Okay, so we did get 4 solutions. Let's see here. So let me just write down the solution set in this case is, let's see, well, let's do negative 3, negative 1, negative 3, 1, 3, negative 1, and 3, 1. So if I label these points, like, label that A, B, C, and D, then this would be B, that would be A, that would be D, and that would be C. Okay, so there's your 4 solutions. And we have one more example to do today, and that's the system x times y equals 6 and 2x minus y equals 1. So in this case, this first equation I'll call, and you can rewrite that as y equals 6 divided by x, which is like y equals 1 over x. So that's going to look something like this. It's going to be a rational function that has a vertical asymptote at x equals 0. So it's kind of like that. And then the other function is going to be y equals what? Y equals 2, let's see, it would be y equals 2x minus 1, yeah, which looks something like that. Slope of 2, so we're expecting here, I think, two solutions, probably one there and one there. Okay, so step 1, I'm going to solve for y. And 2x minus y equals 1. So I get y equals 2x minus 1. And then step 2, I'm going to plug that into the other equation. Well, when I do that, I get x times 2x minus 1 equals 6, which would be 2x squared minus x equals 6. And I should probably subtract 6 over, so I'll get 2x squared minus x minus 6 equals 0. And now I can either factor that, I can try to factor it, or I can use quadratic formula. I think I can factor it, and what I'm going to do is I'm going to look at all the things that would multiply to give me 6. And let's see, I can do 1 and 6, I could do 2 and 3, and that's it, right? And so now I'm looking for things that will add up to give me negative x there in the middle. So I think I can do 2x plus 3 and x minus 2. And does that work? Let's see. Yes, because the 2x times the negative 2 will give me negative 4. And then the 3x, so negative 4x plus 3x is negative 1, or negative x. Yeah, so this works out. Okay, so this factors as 2x plus 3 and x minus 2 equals 0. So either 2x plus 3 equals 0, or x minus 2 equals 0. Well, in the second case, I get that x equals 2. And in the first case, I get that 2x equals negative 3, so x equals negative 3 halves. So now I have my x variables, or my x coordinates. I want to plug those into the linear equation. Would be easiest. So I'll plug x equals negative 3 halves and x equals 2 into y equals 2x minus 1. So then I'll get y equals 2 times negative 3 halves minus 1, which is negative 3 minus 1, which is negative 4. So that tells me that negative 3 halves comma negative 4 is one of my solutions. It's going to be that one. So negative 3 halves, negative 4. And then the other one is when I plug in 2. So y equals 2 times 2 minus 1 is 4 minus 1, which is 3. So 2 comma 3 is my other solution, which would be that one up there. Okay, so then let me just say that the solution set, let's just write it down again, highlight it. Solution set is negative 3 halves comma negative 4 and 2 comma 3. Those are my 2 points in the solution set. Okay, and that's all I had for today. Thank you again for your time. I'll see you in class on Tuesday.